So I'm going to do a little bit of talking about biomass boilers and try to prove to you that actually there's still opportunity for biomass boilers. The boat hasn't sailed. And then Ollie will reprise a session about biomass combined heat and power, followed by EBTech talking about the practicalities of installing those projects. They've been heavily involved in the project that's gone down at Spring Hill, hence why it's pertinent that they're here today. And hopefully we'll have a good session. How many boilers do you need? I think, as we all know, people have put in multiple boiler systems in the last 5 years, whether it's 2 boilers, 3 boilers, 4 boilers. In fact, there's a picture of 3 boilers there. Behind the person taking that photo, there's another 4. And that's what the renewable heat incentive has done. It's made people make investment decisions that maybe aren't necessarily best for energy efficiency, maybe aren't best for logistics, but actually they're best for financial return. Hopefully the renewable heat incentive changes will calm that down a little bit and people will be more considered about the projects they do, and you'll see how moving to bigger boilers can be as good both financially and better for getting projects put together as well. So these are the rates. You saw them earlier in terms of what the rates used to be, now what the rates are going to be. So single rates across the board. So less than 1 megawatt rate on the left-hand column, greater than 1 megawatt rate in the middle. Really, what does that mean in terms of income? Well, if we take the 3,066 hours, so that's a 35% load factor, operation factor, whatever you want to call it. If you had a sub 1 megawatt boiler, then you'd be looking to get around about £117,000 worth of renewable heat incentive income for that project, or an average rate of about 3.8 pence a kilowatt hour. Moving to the new tariff structure, that's going to drop slightly to an average rate of 2.9, and you're going to get about £89,000, but still a reasonable amount of income for the size of project and the size of boiler that is. Moving to 5,000 hours, again, you would have got more under the old scheme on a sub 1 megawatt boiler than you're going to get on the new scheme. But that doesn't mean to say that it's nothing. You're still looking at a relatively high level of income for a boiler of that size running a very long number of hours. And of course, the boiler sizes being what they are and the popularity of the scheme being what it was, is that the 1 megawatt boiler size is something that everyone gets their head around, and boiler sizes and boiler costs reflect that. When you go to bigger boilers, you can actually see that it swings the other way around. So you used to get, if a 2 megawatt boiler, people would say, well, actually, I was getting £117,000 for a 1 megawatt boiler. I'm only going to get £127,000 for a 2 megawatt boiler, and I've got double the amount of heat as well, so I'm going to have to put double the amount of fuel in the front end, and so the difference was a lot more marginal. But of course, as we move that forward, on the new rate, you're going to get nearly £60,000 more, £55,000 more, because the rate has gone up. It's as simple as that, and for a 3 megawatt boiler, the disparity is even greater. And so I think we'll start to see a shift towards boiler projects, boiler sizes that more match the demands of large-scale horticulture, large-scale industry than we have done in the past. Here's a slide I put up in 2013. We ran an event relatively similar down in the Lee Valley in 2013, trying to explain to people what biomass boilers were and how they worked and why they'd be good for horticulture. That seems a long time ago, but these are the fuel costs that we put up then. And really, the wood fuel costs haven't massively changed, or the biomass costs haven't massively changed since then. And if we look at the table today, actually the big changes have been gas is slightly less now than it used to be, and gas oil is slightly less than it used to be. So actually the fuel savings have been less for projects moving forward, but that hasn't dented the popularity. And actually, when you look at the graph of gas oil, actually, I might have it in a minute, you'll see that it dropped off a cliff around about 2013 and went to some fairly low values. But that meant that the biomass projects despite that, biomass projects went ahead anyway. Any fuel suppliers in the room? Oh, good. I'm not going to get ripped apart too much then. But so it's typical cost for biomass there. You see, I've got a slightly different set in my table. I think wood pellets at scale people aren't going to be using. We've been involved in a couple of 1 megawatt wood pellets fired boilers, but really most people end up down the wood chip route. And we're beginning to see grade A wood becoming quite a popular fuel as the cleanliness of that is better regulated and it becomes more of a mainstream thing to do. So I thought I'd put the gas oil price. You can see how that's changed. I'm going to be, shall I be optimistic? Is optimistic the word that oil prices are going up? I don't know whether that's the right thing to say, but oil prices look to be back on the up from a low in sort of early 2016. Oil prices are up, and that will obviously have a balancing effect on biomass projects. I suspect there aren't many nurseries, large-scale nurseries on oil that haven't considered biomass, or at least got a biomass boiler installed. But if they have, I think that's where obviously the big savings can be made compared to gas. Just a quick example: typical 1.5 hectare nursery, 450 kilowatt hours a square metre, if you can call that typical. But that's around about a protected edibles sort of a level. Peak requirement 2.5 megawatts. If you took a 6 to 8 watts a square metre per degree C rule of thumb, you might end up with a biomass boiler around about the 1.8 megawatt size. And someone can beat me up about the capital cost of that later if I've got that completely wrong. But it's around about that order. And disregarding fuel savings completely, there's a payback of around 8 years. So that's just on renewable heat incentive income. And if there's fuel savings to add into that as well, then actually that return is going to be significantly better than is there. And so I put that up as a worst case figure that even if you're considering something new, then biomass still works for some people. What's the point of tariff guarantees? Well, in the world of biomass, not really very much point, especially in the sub 1 megawatt where you can't get it anyway. The idea is to remove the barriers to doing the project in the first place, and when you're talking multi-megawatt systems, where we're talking 5 megawatts plus, then maybe tariff guarantees are an important facet of that. But for most biomass projects, I would say that it actually slows everything down. You've got to go through your preliminary accreditation, you've then got to go through your tariff guarantee process, and by that time you could probably have developed your biomass boiler project anyway. And subjected yourself to some fairly rigid and immovable guidelines and rules. So probably fine that actually if the biomass boiler market calms down a little bit in terms of the rates, which it will do, that most biomass projects don't need a tariff guarantee, but when you start looking above that 5 megawatt level, then maybe it will still be worth considering. And if you've got financiers that are incredibly nervous, then it probably, or almost certainly, will be useful for them. What the changes in regulations do is sort of open up this market of additional capacity. So the additional capacity rules state that if you put another biomass boiler in within 12 months of the first one and you join the two together, it's considered as a biomass project in its entirety of one size. But actually, if you do a biomass project and then you wait 12 months and you put another one in, that's called additional capacity. What you've done is you've secured the rate on one boiler, and you're going to get what we call the rate of the aggregate capacity on the second system. So currently you'd get your 5 pence a kilowatt hour if you already established your 1 megawatt boiler. You put another 1 megawatt in after 12 months, you get your 2.08. And moving forward, it will be your 2.96. And so as the rates are going up, if you've not quite got enough capacity in your existing 1 megawatt system, now you can just add another boiler of the appropriate size to get you over that extra requirement, and you can still get a reasonable return for it without having jeopardized your first one if you're post 12 months. What that does mean is that you can do it on a a biomass boiler system. If you've got 2 biomass boiler systems already and you want to add another one in the middle and join all 3 together, that can't be done, because then you're combining your 2 systems that are already accredited together, and that's against the rules. So you could do it to one of the systems, but not on to the other. Needs appropriate metering. Metering is a massive pitfall in RHI. The more meters, the better in the world of Ofgem, and sometimes it gets ridiculous and you have to bring Ofgem back down to earth and say, actually, you don't need all these heat meters. We can do it like this or like that. But heat meters are not quite the expense item that they used to be at certain scales. And so just to reiterate that point, so expansion of existing systems, if you haven't got quite enough capacity, and you didn't want to split your heating system up, so you've not considered any more biomass because you didn't want to do that, now might be the opportunity to think about that. But obviously, you're still unable to combine existing systems. What I would say is that, I have read these new regulations for my sins. Only about 30 pages of it relate to accreditation, albeit that's the bit that we all worry about. The rest of it are about staying accredited. And staying accredited is more difficult than getting accredited. And the rules surrounding that they have changed, and they can change, and the interpretation of those rules is continually changing within Ofgem as they come across cases that they don't particularly like, and then they bring up a new rule, a new thing to measure everyone against. Reiterating Brian's point about why do some systems take so long to get accredited is someone somewhere's done something, and then Ofgem have decided that actually they don't want that to happen, so they bring in a rule about it, and then they apply that to all systems already in the pipeline, so they go back to the beginning and start all that accreditation process again. So ongoing obligations are incredibly important. Your project will be assessed against some of that at accreditation process, but also moving forward and at any audit, at any time you submit periodic data, any time you've got to submit a fuel sustainability statement, then you are into assessment against ongoing obligations. And there's another 60 pages of that in the regulations, and it can be quite onerous. Some of them are, if you change your system hydraulically, you've got 28 days to tell them about it. And if you don't tell them within 28 days, then you're in breach of your ongoing obligations, and they can decide to withdraw your payment. That is the threat that it is their ultimate threat. We can withdraw or suspend or remove entirely your payments. And so they run that down our throat on a regular basis for people that are in breach of these ongoing obligations. Changing of fuel, if you've lodged in your accreditation pack that you're going to burn wood chip, virgin wood chip, and you decide to burn grade A wood chip, then that is a change of fuel. You need to tell them about it. You need to make sure that your emissions criteria are met. You need to make sure that your boiler is capable of burning it, that you've got all the right processes in place. And the ways of measuring that, might not be under the biomass suppliers list, in which case you've got to do new fuel measurement and sampling and all of these sorts of things. So don't forget about these ongoing obligations. This isn't a fit and forget technology. It's worth keeping a close eye on what you're doing and making sure that you keep track of where your fuel is coming from, what it consists of, and who's delivering it. When it comes down to environmental permits, they're not actually required in the RHI regulations to get payments. However, the Environment Agency get quite upset if you're burning things what they deem to be waste. And grade A recycled wood is deemed to be a waste, and so you need an environmental permit. And that is as onerous in some cases as having a registered fuel supplier on that permit, and if you decide to buy it from someone else down the road, then you have to change your permit as well. So do be aware of some of the issues around permitting and moving fuel supplier. And don't forget regular checks. Most of you will have seen or touched or felt or heard a biomass boiler. Servicing maintenance, making sure things are still working. Importantly, check your heat meters on a regular basis. One thing to remember about biomass boilers for anyone who's got a system, make sure that heat meter is read weekly, daily, at least as frequently as that. Because when things go wrong and you haven't noticed them, it's really difficult to track back and work out what you should be paid and make that case to Ofgem. And that's as much as I'm going to say about biomass boilers. And there's a question in the corner.
What is your position on this, the
Yeah, I don't know what the renewable heat incentive regulations are going to contain when it comes to that, and maybe that is part of the reason why the regulations have been redrafted. But I don't know very much about how that's going to affect RHI projects ongoing or currently.
Supposedly, if you do, for example, wastewood grade B, you won't be able to do that if you have to do it after the European directive.
Right, okay.
Because it becomes just way too expensive with the filters and the monitoring system on it.
Okay, I shall keep a watching eye on that then, as to see how that's going to affect things. And obviously with the implication of coming out of the EU, whether that will be adopted as a legislation going forward will be an interesting thing to think about. Anything else? Neil?
John, obvious question for us. Is it possible to switch between the old tariff system and the new merged one?
No. If you're already accredited, you're already accredited. And in the early days where the rates were a penny and then they went up to 2 penny for large biomass, people tried that and that was not allowed. Okay, I shall hand back over to Ollie to take us through some biomass combined heat and power.
Right, biomass CHP in horticulture. So what do we mean by biomass CHP? Obviously it stands for biomass combined heat and power. Many of you may be familiar with combined heat and power in the context of a gas engine, which largely they give off about as much heat as they do electricity. I mean, a gas engine obviously quite similar to your car. Other than obviously the fuel, the size, and the fact it's tuned to deliver electricity. How then do we capture electricity from biomass? Well, there's a number of ways we can do it, but it all starts with a biomass boiler, which John has just gone through. There are other ways to do it, which I'll come on to in a little bit, but as far as the RHI is concerned, that's not necessarily biomass CHP. Right, so now we've got our heat source. It's just a case of deciding which generator that we want to associate with that heat source. The 3 varieties that are commonly employed are steam turbine, which you'll probably all be fairly familiar with, screw expander, which is effectively similar to a screw compressor, just in reverse, and the organic Rankine cycle. So steam turbines, as I mentioned, relatively straightforward, and it's a well-proven technology. The requirements are steam, obviously, generally at quite high pressures, so you're talking sort of 50 bar, 500 degrees C. And the turbine, essentially it extracts all the thermal energy from that steam, often in numerous stages, designed for specific temperatures and pressures as it goes through the turbine. They operate at fairly high speeds, especially compared to other types of turbine like a hydro turbine or even a wind turbine. They're more like engines in that regard. And the steam from the back end can either be condensed, that helps to draw through the steam at a quicker rate. Typically that's what goes on in power stations. You get a higher electrical efficiency up towards about 80%. It does mean that the pressure, as you can see there coming out the back end, is negative and the temperatures are not great. So you don't necessarily have to condense the steam out the back end. You can simply have a normal sort of heat exchanger to extract the heat, thereby making it a combined heat and power system. So secondly, we've got the screw expander. It's another means by which steam from biomass can be utilised to generate electricity, an example of which you'll be seeing today. The principle is based on the Archimedes screw, which was originally intended to raise water from one level to another. That type of technology can be seen in pumping stations, hydroelectric systems and compressors, and now obviously generators as well. The system utilises 2 rotors which turn at relatively slow speeds compared to a steam turbine, and you can power it with wet steam as opposed to a turbine. So it can be a mix of both effectively steam and water to generate. You can't use that in a turbine simply because of corrosion effects. And also, while a turbine has very fixed sort of operating conditions, so fixed pressure that it needs, fixed temperature, a screw expander can operate at a variety of different pressures and temperatures. Sorry, so just a quick note on steam and why we use steam and not hot water to generate electricity. A brief example. To heat 1 kilogram of water from 10 degrees centigrade to 100 degrees centigrade requires 375 kilojoules. If you were to take that 1 kilogram of 100 degree water and turn it into steam, you would need something in the region of 2,300 kilojoules. So inherently, there's a lot more energy in steam than there is in water. So on to the ORC. Sorry. It stands for the organic Rankine cycle, and it's a method that doesn't normally use steam as a heat transfer medium. You can see this example here is powered by thermal oil at typically around 300 degrees. As the name suggests, the fluid used within the generator itself is an organic material with a high density and a lower boiling point than water. As such, it can generate it can generate electricity off of much lower heat sources. So industrial waste, biomass combustion, or geothermal heat. The low temperature heat is converted into useful work via a turbine or a screw expander, as an example, with the fluid being condensed once again. It's gone through its cycle. You then use the boiler and the thermal oil to evaporate that material again and put it through the turbine. So as I briefly mentioned before, there are other methods to extract energy from biomass. Gasification is a good example, where wood chip is heated up in a low oxygen environment. It drives off the gases and then you combust those gases. So strictly speaking, and as far as RHI is concerned, that's biogas combustion and not biomass CHP, which is why I'm not addressing it today, but it's something you should be aware of. Design build considerations. Obviously, budget is a key one. Different technologies cost different amounts of money. You should be looking at your electricity supply to your particular site. Whether you can export, you might not be using all the electricity at the same time as you're generating. Operation and maintenance varies quite considerably for these particular technologies. A steam turbine, obviously going at several tens of thousands of RPM, compared to a Helix screw expander, for example. The operation and maintenance criteria are going to be different. As an example, this is actually from a gas turbine, but you can see sort of corrosion effects or a heat hole, whatever you want to call it, and that particular gas turbine required a full rebuild, which put it out of action for a month or so. So onto the rates or the incentives available. So whichever technology you go for, biomass CHP supported by the RHI. And that is the primary sort of incentive available for biomass CHP. You were able to get renewable obligation certificates, or ROCs, but that scheme came to an end at the end of March. And the schemes replacing it are considerably more complex and probably not to everyone's liking. it'll be largely aimed at the massive sort of systems. So most systems will be set up to make use of heat directly from the biomass boiler as well as through the CHP, as you can see in the top left there. For that heat, you would get the biomass combustion rate. Any heat that's passed through the turbine or screw expander will get the, and then subsequently used, will get the biomass CHP rates. As it mentions there, you'll get your export payment if you're exporting to the grid, or potentially your offset of using imported electricity from the power you generate. CFDs, yeah, as I mentioned, it's probably not going to be very popular, but it is an incentive for electricity that is available. Again, RHI criteria, so John's briefly gone through those. Particular ones that are concerned with biomass CHP are emission certificates. So particulate matter and NOx, there is a limited amount of emissions associated with those that you can claim the RHI on. Sustainability criteria for your fuel. So yeah, anyone using fuel that's been intensively harvested, the sustainability criteria basically has an emissions limit in terms of greenhouse gases that can be associated with that fuel. Again, plant must be new, and the plant must provide heat for eligible purposes. So heating a building, heating water, or carrying out a process within a building. Once again, metering is important, which is the same slide that we've seen before. A few brief examples. I'll go through the first one, and I think I'll leave the other two as we're running short on time. But effectively, this is a 100 kilowatt output steam turbine. The capital cost for the whole system, including boiler, you're going to be looking at about £800,000. About 3,000 tonnes of wood chip, so a significant fuel cost, but you can see your RHI and your electricity offset. Okay, I've put 9p there. It's probably a bit high, but if you're using it all yourself, that's the sort of figures we'll be looking at. A net income of about £200,000 a year and a payback of about 4 years. The other two examples I've put in there, so I've put a screw expander system in there. As you can see, there's a lot more electricity generated by this particular example. It depends what your particular requirements are, whether you're running lights, etc. And a payback of 3.3 years there. ORC systems, typically they are extremely expensive, so the paybacks are generally longer, but the electricity generation side of things is very efficient. Okay. Right, I will pass over to Simon now from EBTech, just to go through a bit more about biomass CHP.
Good morning, ladies and gentlemen. My name's Simon Ingleby. I'm a design engineer for EBTech, where we design and build biomass energy systems and integrate into the glasshouse heating and distribution. Thank you to John and team for the opportunity to present to you. I've tried to break down a project into what I would call sure steps. Not a comprehensive list, but gives those areas to consider, starting with identifying the need, hopefully the obvious one. Basic needs. I'm not going to read them, I'll just say energy, power, fuel costs, subsidy, and return. Or, as an acronym, never mind. Doing the sums. Easy at this stage. What might it cost? What might I save? What will it make? Evaluating your site. Consider the physical constraints of the site. Do we build into existing boiler houses? Very rare, as these tend to be congested already. Build new. Consider things like lorry movements for fuel deliveries, adequate fuel storage, shadows to the glass house, maintenance of the plant. Don't make things too tight. However, of great importance is the grid connection for the power export. Costs for a grid connection vary wildly and are very site specific, so this has to be investigated early. It may be the deciding factor for this part of the project. CHP gives us a very large heat output. Evaluate the existing thermal storage capacity and demand for your existing site. So consider extra storage to release the needs for fossil fuel backup. How will it integrate into the existing systems? Maybe time to rationalise an old inefficient distribution system. With seasonal demand, there's a balance to make between electrical generation and heat demand. That heat has to go somewhere. Heat destroyers? No, not the answer. Consider new applications to complement your business, like drying, fuels, grains, even agricultural sludges. Back to the sums again. The data's getting a little bit more complex now. Your new build is going to usually involve planning permission. Involve at this stage a planning consultant. Costly but invaluable, as they can start the process with a scoping document that dips the toe into the muddy waters of the planning authority. Considerations like noise and traffic can be overcome by tapping into the authority's green credentials. Give as much detail and visual information as possible. With the right wording, this can be turned into advantage. The planning and legislation will come up and beyond the plant realisation, so fix the terms with that consultant to stay in budget. Allow a contingency and then double it. Time to select technology. Consider these key factors: running hours, fuel, space, and of course budget. Which type of biomass fuel is a fundamental decision. In our experience, the most effective is clean recycled timber, grade A. Usually old pallets, shredded. However, mixed wood waste is in the frame at the moment and offers attractive cost. However, the plant has to then be WID, or Waste Incinerator Directive, compliant, which dramatically reduces the choices of boiler and attracts much higher cost for monitoring. Fuel feeding systems all offer their own advantages. Walk-in floors, the most common. Different designs peculiar to each manufacturer. Make sure they're robust, big enough for a trailer load, and drive on. With all these technologies, capacity might be the key. Investigate when taking up references. What space is available? New build? What's the maximum height? Existing building? What can we fit in? How to produce the power? We've gone through that. Steam through an expander like the Helix system, or thermal oil through an AUK unit. Each system needs the relevant matching biomass boiler and is usually bought as a total package. Time to select your partners. Nope, avoid those guys. It should go without saying that an investment on this level requires top marks in each of the categories here. Reference site visits, not the easiest with confidentiality issues. You may have to venture abroad. Buildings and civil works, pick from a local market, but pin down with a contract. Extending the heating circuits, use a partner that understands your system fully. The project is now beginning to take shape. Things are coming together. Answers are now coming into the following. Back to the sums, they're getting harder now, especially as capital equipment costs begin to appear in the minus column. There are figures to put in the plus columns too. Time to go to the next sure step. Let's start the build. Design's fixed, building designed. Time to build. Now, as an engineer, I question the term turnkey installation. A project has to be carried out using a team of different disciplines, and some of those need to be the guys local to you that you've helped develop your business. Make the project incorporate these guys too. However, in a grand designs phraseology, engage a project manager. He will be needed to pull the team together and watch the individual responsibilities in line with the total project. Manage the budget, the programme, and police the health and safety. Watch out for construction costs, like cranes, specific to the site, but there are some heavy lumps to assemble. Once in place, get the builders back to close the roof up and make the plant room watertight. There's a lot of work that needs to be done that involves all the engineering disciplines. This is where that project manager will earn his money. Fuel in, fire it up, run trials, commissioning, operating, training, a critical phase. Call in John, get the rubber stamp of approval. Finish off the building, tidy up the site. Job done. Happy endings. Realise the income. Invest the money. No. That's better. More growing space. Did I mention we also build glass houses? Thank you.